So last time I showed you guys how to use double integrals to find the central of a region, and we got these two formulas here. But here's a bigger question. Why do we need this? Because maybe you are like, I'm happy with the single integral formula. I don't want two integrals in my formula. Well, sometimes if we have a more complicated region, maybe this is the way to go. So today, I want to give you an example on just that. Check this out. I'm going to give you a pizza like this. And this is meant to be a perfect circular arc. So this is a sector. And let's say from here to here is 4. And this angle is pi over 3. Okay, how do we find the center of this region? Maybe we can cut this into a triangle and this part. And this is like a wedge. You have a pizza and now you have a potato wedge. And then do all that stuff. But it's not going to be too easy. Yeah, it's doable, but don't do it. And if you really want to do that, like y is equal to whatever this equation is, and y is equal to whatever that equation is, and then use the x bar, y bar formula with an integral only, well, in the next video, I have to make another crazier function, so you really cannot do that anymore. But I think many of you guys have noticed the key to do this is to actually use polar coordinates. Because in the polar world, this right here is simply r is equal to 4. That's it. So that's the key. We will use polar. And let me remind you of all the formulas. X is equal to r times cosine theta. Y is equal to r times sine theta. X squared plus y squared is equal to r squared. And finally, dx dy equals dr d theta. Don't forget the r. Extremely important. All right, with all this being done, here we go. First, let me remind you guys how to find the area when we have a polar situation. Area equals integral going from theta 1 to theta 2. 1/2 times the function r, square that, and we have d theta. So let's compute the area of this region real quick. And in fact, you don't have to do integration. Since this is just a part of the circle, you can use pi r square and then take the portion out of it, but I will do integration. Theta 1, beginning theta value is 0. The ending theta value is pi over 3. And then 1/2 r is just a 4, and then square that. Sometimes if you have a different polar function, such as r equals 1 plus sine theta, you just have to put that function down here. And of course, the integral gets like much harder than this. But this one is not bad. We have 8, and then we just have to multiply by pi over 3. So this is 8 pi over 3. And let me just make a quick note right here real quick. Okay, x bar. We have 1 over a, and a is 8 pi over 3. And then double integral. Now here's the deal. Look at dA. This right here, in the rectangular sense, is either dx dy or dy dx. But don't put that down because we have this. Much better. So write down r dr d theta. But now, don't put down x right here anymore though, because x is not allowed in the r world. It's also not allowed in the theta world. Don't worry. We have this. So write down r cosine theta. Okay, do the r first. R goes from 0 to 4. Theta goes from 0 to pi over 3. This is a much easier integral to compute compared to if you want to use the rectangular method. All right, this is 3 over 8 pi. And notice right here, we can actually separate this into two single integrals. Let's put on all the terms with r first. That's r squared, dr, and that will be integrated from 0 to 4. And then rest, d theta, cosine theta, and this right here. Earlier it was this integral for the r, and now we multiply by this integral. And we have cosine theta. 3 over 8 pi. We get 1/3 r cubed. Plugging 4, we get 64 over 3. Okay, integrate cosine theta, we get negative sine, we get positive sine theta, and then we go from 0 to pi over 3. Pi over 3, okay, I draw the little triangle. I still have to do this sometimes. We get square root of 3 because it's 60 degrees, and that opposite over hypotenuse. Square root of 3 over 2. And don't forget to plug in 0, but sine 0 is 0, so we're good. So this right here, square root of 3 over 2. Now, cancel, 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 reduce, all that stuff, right? Yeah. So on the top, 4 square root of 3 over pi. Now, moving to y bar. All right, pretty much the same thing. Y bar equals 1 over a, which is a pi over 3. Double integral y, put that down. So r sine theta dA is r dr d theta. And then still we go from 0 to 4 for r, 0 to pi over 3 for theta. So that's 3 over 8 pi. Again, break this down. We have r, dr, ds, all that stuff, and this is this integral. And then the rest. So you just have the cosine version, unlike the one earlier. We have sine version now, so yeah, and then it's pi over 3. Okay, so 3 over 8 pi, 64 over 3. Okay, for this, we get negative cosine theta, and then we go from 0 to pi over 3. Okay, plugging this, we actually get negative 1/2, right? Cosine of pi over 3 is 1/2. Minus negative, so it becomes plus. Be careful, plugging 0, we have 1. So this right here, we get 1/2, positive. So positive 1/2. Okay, cancel, cancel. This is 1, this is 8, this is 1, this is 4. Cancel this out. So 4 over pi. So maybe somewhere here, I'll just write down this answer here. That's it.